You know, when you think about crypto, you probably think fast, right? Instant transactions. But with Bitcoin, there's this weird thing called difficulty. And it's not a bug, it's actually a feature. Today, we're going to dig into Bitcoin's mining difficulty and figure out why a system that could be super fast is deliberately slow.
So it really all boils down to this one simple question. We've got computers that can do billions of calculations a second, right? They're lightning fast. So why on earth does it take, on average, 10 whole minutes just to add one new block to the Bitcoin blockchain? It just sounds so inefficient, doesn't it?
Well, here's where it gets really interesting. That 10-minute wait, it's not a bug. It's not because the tech can't go any faster. Nope, it's a feature. A carefully, deliberately designed feature. And honestly, it's one of the most crucial security measures in the entire Bitcoin system.
All right, so first up, let's talk about this 10-minute puzzle. We're going to unlock the real reason behind that wait.
Okay, to really get why this 10-minute rule exists, you first have to understand the trust problem. Think about it. Bitcoin is decentralized. There's no big bank, no central authority in charge. It's just a network of strangers. So how in the world do you get thousands of people who don't know each other to agree on what's real and what's not? Who do you trust?
The initial solution from Bitcoin's mysterious creator Satoshi Nakamoto was actually pretty elegant and simple. The rule was the longest valid chain wins. Whatever version of the ledger is the longest, that's the one the network trusts as the truth. Simple, right? But yeah, as you can probably guess, this creates a whole new problem.
Because what if an attacker just makes a longer chain? If creating new blocks was super fast and easy, what's stopping some bad actor from going off in a corner, creating their own private chain filled with fake transactions, making it grow really, really fast, and then tricking the whole network?
I mean, the playbook for an attacker would be almost too easy. Step 1, create a secret, private chain with a bunch of phony transactions. Step 2, use a ton of computing power to make it grow way faster than the honest chain. And then Step 3, broadcast this new, longer, fake chain to everyone. The rest of the network, just following that longest chain is law rule, would get totally duped and accept the fraud.
And that right there is exactly why creating a new block has to be hard. It has to be difficult and take time, which brings us to the genius, if counterintuitive, solution. You have to deliberately slow the whole thing down.
This solution has a name you've probably heard, proof of work. And a great way to think about it is like a giant digital speed bump for the entire network. It's a system that basically forces computers, we call them miners, to do a whole lot of work. They have to burn real-world energy and spend time solving a super complex cryptographic puzzle just for the right to add the next block.
So, to make sense of this, you can think of it in a couple of ways. It's kind of like a global lottery. You have millions of computers all buying tickets, which are really just guessing numbers, over and over trying to find that one single winning ticket. Or another good analogy, picture an incredibly complex digital lock. Every miner on the network is trying different combinations at the exact same time, but only one is going to find the right one and unlock it first.
And here's the kicker. The whole system is calibrated so that with all that computing power from all over the world guessing at once, that winning ticket is found, or that lock is picked, on average about once every 10 minutes. That delay, that built-in difficulty, is what makes it pretty much impossible for one single attacker to get ahead of the entire honest network.
So, problem solved, right? We just make it hard. Well, not quite. There's another piece to this puzzle. What happens when computers just naturally get faster over time, or when a whole bunch of new miners join the network? That 10-minute target would get shattered. And that brings us to the next brilliant piece of the system, the difficulty adjustment.
You know, technology never stands still. Computers are always getting faster, and the number of people mining is always changing. If a ton of new computing power joins in, that puzzle gets solved way faster than 10 minutes. If a bunch of miners leave, it takes longer. Either way, you lose that predictable 10-minute security window.
And this is where we get to the heart of it, mining difficulty. It's literally a number, a variable, that's written right into the Bitcoin code, and its whole job is to control how hard that puzzle is to solve. And it's not a static number, it's dynamic. It's a self-regulating mechanism designed to keep the entire network right on schedule. So here's how this self-correction actually works. Every 2016 blocks, which works out to be about every 2 weeks, the network basically stops and takes a look at the clock. It checks the average time it took to mine those blocks. If it was faster than 10 minutes on average, that tells the system there's too much mining power out there, so the difficulty gets cranked up.
If it was slower than 10 minutes, it means there's not enough power, so the difficulty is lowered. It's this beautiful, constant feedback loop, all to maintain that 10-minute target.
Okay, so we've got this really clever, self-regulating system. It's amazing, but this design has a pretty major unintended consequence, and it's one that kind of flies in the face of the whole goal of decentralization.
See, as the difficulty keeps rising, miners need more and more powerful computers. They need to burn more and more electricity just to have a shot at solving the puzzle and getting that reward. It creates this massive economic arms race. And what happens? Well, it eventually becomes totally unprofitable for the little guy, for the individual miner at home. They're forced to shut down. The only ones who can stay in the game are the massive operations, the ones with huge economies of scale and access to super cheap power.
And this is what that looks like in the real world. A technology that was specifically designed to be distributed and decentralized has, ironically, become really centralized. If you look at the network's mining power today, most of it is controlled by a handful of massive mining farms and these things called mining pools, which is where a bunch of smaller miners team up. This concentration of power is a huge departure from Satoshi's original vision.
So yeah, the system is brilliant, but it's not perfect. We've just talked about the economic side effects, but there's also a tiny, little flaw hidden deep inside the original code. It's this great reminder that even its legendary creator was, human.
It's actually what you might call a rookie coding mistake, and it was made by the one and only anonymous creator, Satoshi Nakamoto.
So here's the bug. Remember that difficulty adjustment that happens every 2016 blocks? Well, the calculation is supposed to look at the time it took for all 2016 of them, but the code, it actually only looks at the first 2015. It just completely ignores the last block. It's a classic off-by-one error. Now, in the grand scheme of things, it has almost no effect on the network, but it's just this fascinating human fingerprint left behind in this giant automated machine.
So when you put it all together, what do you have? You've got this elegant solution, proof of work. You have a brilliant self-correcting mechanism, the difficulty adjustment. But you also have these major unintended consequences and even tiny human errors baked right in. And this balance, this trade-off between brilliant design and messy real-world outcomes, it really makes you wonder, what does it actually take to build a truly decentralized future? That's something to think about. Thanks for joining me for this explainer.